If you remember what I said in the first lecture video, I said that physics is an empirical science. So the core business of physics is about doing experimentation or observation. And when we are doing an experiment or observation, we are measuring physical quantities. Now, depending on how you measure or what device you use to measure, you may get some of the measurement results more precise than the other. For example, if you try to measure the thickness of a paper, the result that you get from using, for example, Fresnel caliper is going to be less precise as compared to the result you will get if you use micrometer screw. So, how is this difference in the precision reflected in your measurement result? Now, the answer lies in this concept called significant figures. A measurement result that carry more significant figures are supposedly more precise than those with less number of significant figures. The more numbers there are, the more precise your measurement is. So what we're going to do now is to learn how to count the number of significant figures in your result. Now these are the rules of significant figures. Number 1, all non-zero figures are significant. So for example, the first point here, 25.43. Now there are 4 significant figures here because 2, 5, 4, and 3, all 4 numbers here are significant, whereas 25.4 has 3 significant figures because there are only 3 numbers there, 2, 5, and 4. The second rule is that all 0 between non-zero digits are significant. So for example here, 203.4, the 0 in between 2 and 3 is significant. So altogether, this number carry 4 significant figures, namely 2, 0, 3, and 4. The third rule is that all zeros to the right of a decimal point, which follows a non-zero digits, are significant. So for example, this number 43.0 has 3 significant figures because this 0 is to the right of a decimal point and it follows a non-zero digit, which is 3. However, if the zeros are used only to indicate the position of the decimal place, these zeros are not significant. So this number 0.043 has only 2 significant figures which come from the number 4 and 3. The 2 zeros here are not significant. Another example will be this number 0.00040. How many significant figures are there in this number? Now, this number carry 2 significant figures. Where does the 2 significant come from? It comes from this number 4 and this number 0. Now, the last 0 is significant because this 0 is to the right of a decimal point and it follows a non-zero digit, which is this number 4 here. Whereas these 4 zeros here are not significant because they are only there to indicate the position of the decimal place. And finally, the last rule is that if you are dealing with the whole numbers with a lot of trailing zeros, those zeros behind, like for example this number 500, now these zeros may or may not be significant. So for example, this number 500 here, it can carry 1, 2, or 3 significant figures depending whether we count both zeros as significant or just one of them or none at all. So in such cases, we normally use scientific notations, or back in secondary school some of you may call this standard form, to describe the number. So in scientific notation, the number is expressed as a multiplied by 10 to the power n, where a must lie between 1 and 10 and n is an integer. So 500 can be written as 5 multiplied by 10 to the power 2, which is in that case, it only carries 1 significant figure because of this number 5. But it can also be written as 5.0 times 10 to the power 2, which in that case it carries 2 significant figures because of 5 and 0. Or 500 can also be written as 5.00 times 10 to the power 2, which carries 6 significant figures because of the number 5 and the 2 zeros here.